So in the previous video, we reviewed properties of real numbers under the operations of addition and multiplication. In this video, we're going to look at properties of matrices under the operations of addition and multiplication. And then in subsequent videos, we're going to go over how to prove some of those properties. So if we have matrices A, B, and C, so these are capital letters, so they're indicating that we have matrices because capital letters are the convention. And then scalars, little a, little b, little c, that indicates, because these are lowercase and scalars, that they are real numbers. Numbers are just numbers living on the real number line. And what we want to do is identify that matrix addition and scalar multiplication have the following properties. So we see that matrix addition is commutative. The order in which we add two matrices doesn't matter. Matrix addition is associative. So if we have the sum of three matrices, we can add the first two matrices first and then the third, or add the second and third matrices first and then add on the first. There's going to be an additive identity. So remember from the previous video, an additive identity for the real numbers was a number you could add to any real number without changing its identity. So in this case, we're going to have what's called the zero matrix. So the additive identity is going to be a matrix of all zeros. We have a distributive property for scalar over the sum of two matrices. We have a distributive property for a matrix distributing into two scalars. So we have two distributive properties here. We're actually going to see that we have another set of distributive properties here. So four sets of distributive properties. And then we have an associative property involving scalar multiplication. So this says, hey, you can multiply the scalars first and then multiply the result by the matrix, or you can multiply the scalar into the matrix first and then multiply by the other scalar. So these give us, when we're doing calculations that involve multiple matrices and scalars, what these properties do is allow us some freedom in terms of how we do the additions, the multiplications. These are really identifying to us the order in which we can do things. So properties for matrix multiplication. Matrix multiplication is associative. So we have an associative property. So if we have the product of three matrices, we can multiply the second two matrices first and then the result of that product by the first matrix, or we can group the first two matrices and then multiply the result of that product by the third matrix. Notice that the commutative property is missing for matrix multiplication. So in general, if we have the product of two matrices, A times B won't be equal to B times A. And we've seen this already, but we'll probably take another look at it again in another video. We have a multiplicative identity. So this is going to be what we call an identity matrix. And we'll do a separate video where we cover the multiplicative identity. Remember from the review video, multiplicative identity just means, hey, we need a matrix. In this case, we're naming it I for identity, such that when we multiply it by a matrix A, it preserves the identity of that matrix. And then here we have an associative property that tells us how we can associate if we have the product of two matrices and a scalar. It shows us that we can group these in different ways. So these are the properties for matrix addition, matrix multiplication, and scalar multiplication with matrices. So these are properties you probably should write down and put into your notes. And then we'll take in a couple additional videos, we'll prove a couple of these properties, because in the homework it's customary for you to be asked to prove a property, and it's pretty customary for proving a property to show up on an exam as well. So we'll do a couple of examples in a couple videos coming up next.